Hello, my name is Muhammad FARIS bin Muhammad. I from Group 5 and class EC110-1C.
Assalamualaikum, my name is FITRI bin FIRDOUS and I'm from class EC110-1C and I'm from group 5 in that class.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nawal Azryn binti Muhammad AZHAR from class EC1101C, also from group 5. Today, we would like to show you one subtopic from application of differentiation, that is related rates. Related rates are complex problems that involve finding a rate at which a quantity changes by relating to other known values whose rate of changes are known. For instance, if we pump air into a donut floater, both can be solved, but it's much easier to solve the volume rate of change. Take note that the related rate of changes are generally expressed in terms of time. The objective that we can get. First, we can express changing quantities in terms of derivatives. Second, we can find the relationship among the derivatives in given problem. Third, we can use the chain rule to find the rate of change of one quantity that depends on the rate of change of other quantities.
Okay, so for MAT183 assessment 3, the question is Jim, who is 180 cm tall, is walking toward a lamp post which is 3 meters high. The lamp casts a shadow behind him. He noticed that his shadow gets shorter as he moves closer to the lamp. He is walking at 2.4 meters per second. Question A. When he is 2 meters from the lamp post, how fast is the length of his shadow decreasing? And for the question B, how fast is the tip of his shadow moving? The position of the man and the lamp post is shown in the diagram. In the question, there is mentioned 2.4 meter per second dx. So dx over dt will be 2.4. Okay, so for the dy dx, man over lamp equals to man distance over lamp distance, which is 1.8 over 3 equal to y over x plus y. So the first step is to bring x and y to the left side and t to the right side, so there will be multiplication. So 1.8x plus 1.8y equal to 3y when the multiplication is done. So when 3y is bring to the 1 over 8y is bring to the right side, there will be minus, which will be 1.2y equal to 1.8x. So y will be 3 over 2x after 1.8 over 1.2. So dy dx will be 3 over 2. Okay, so for the equation, we got the dx over dt, which is 2.4, and dy over dx, which is 3 over 2. So we need to find the dy dt will be dy over dx multiplied by dx over dt, which is equal to 3 over 2 multiplied by negative 2.4. It will be negative 2.4 because the distance is decreasing. So after the multiplication is done, the answer will be negative 3.6 meter per second. So the shadow decreasing at 3.6 meter per second.
Okay, so I will answer this question, but I will read this question first. Okay, Jin, who is 180 cm tall, is walking towards a lamp post which is 3 meter high. The lamp casts a shadow behind him. He noticed that his shadow gets shorter as he moves closer to the lamp. He is walking at 2.4 meters per second. So I will answer the B question. How far is the tip of the shadow moving? And the question of A, Fitri will answer it. So first we need to draw the diagram. X represent for the length of his shadow, and Y is represent between Jim and the lamppost, the distance of Jim and lamppost, okay, and Z represent for the tip of his, the Z is represent for the distance between of the tip of his shadow and the lamppost. So we need so first at all we need to express Z in terms of X. Okay, X per Z equal to 1.8 per 3, and then I got Z equal to 5 per 3X. So we need to differentiate Z because we will need to use it in next step. Okay, so I differentiate Z and I got the Z per dx equal to 5 per 3. Okay, so we need to use this kind of formula. Okay, so the Z per dt is the rate of change, the tip of the shadow moving, and the Z per dx is 5 per 3, and dx per dt is represent for the represent the distance between of no, the dx per dt is the rate of change the length of his shadow. Okay, so Fitri answer the question A, which is he want the rate of change the length of his shadow. Okay, so he got negative 3.6. Okay, so we need to multiply it, which is 5.3 times negative 3.6. Okay, so I got negative 6 meter per second. So the tip of his shadow decreasing by 6 meter per second.
The conclusion that we get. In the conclusion, we can conclude that objectives that we use in these problems are accepted. The solution that we use to find the value of rate are the same.